Welcome to the Deep Dive, where we unpack a stack of sources to extract the most important nuggets of knowledge and surprising insights just for you. Today, we're plunging into the fascinating world of manufacturing, specifically how digital transformation is fundamentally revolutionizing the industry. We've compiled some fantastic material, really interesting stuff that touches on everything from IoT and AI to predictive maintenance and digital twins. Our mission today is to cut through the jargon, uncover some truly surprising facts, and help you grasp how these cutting-edge technologies are not just boosting efficiency, but critically extending the lifespan of valuable manufacturing assets.
Yeah, and what's truly transformative here, I think, is how these digital strategies are shifting manufacturing from, always reacting to being powerfully proactive. It's fundamentally changing how plant owners and managers don't just operate, but how they envision the future of their entire operation. This isn't just about small tweaks. It's really about building a resilient and sustainable future for the industry as a whole.
Okay, that's a powerful vision. So let's unpack this core idea. When we talk about digital transformation in manufacturing, what exactly does that mean, on the ground?
Well, at its core, it's the seamless integration of digital tools and technologies across, every single aspect of manufacturing. Think of it as creating a kind of digital nervous system for the entire production process. This leads to dramatically improved efficiency, higher product quality, and just better overall decision-making. Technologies like IoT, the Internet of Things, artificial intelligence, and predictive analytics, they all come together to enable real-time monitoring and analysis of what's known as overall equipment effectiveness, or OEE, which is a critical metric for understanding how productive your machinery truly is.
So it's far beyond just automating a single machine or a single step then, right? It's much more holistic, almost like weaving a digital thread through absolutely everything.
Precisely. Yeah. Exactly. The journey extends way beyond traditional automation. It reaches into areas like intricate supply chain management, precise production scheduling, and even proactive maintenance. A key enabler, and this is really crucial, is edge computing. This means processing data closer to where it's generated, like right there on the factory floor, rather than sending it all off to some central cloud. That gives you real-time visibility and enables advanced predictive analytics in the moment. For example, General Motors, they implemented digital manufacturing processes and saw a very tangible 20% reduction in downtime across their operations.
Wow, a 20% reduction in downtime, that's massive. But when we talk about all these digital pieces, IoT, AI, edge computing, how do they actually integrate? How do they all fit together into one cohesive system?
Yeah, good question. Industrial digital transformation aims for truly unified operations and management. That's the goal. This is achieved through integrated platforms, things like manufacturing execution systems, MES, which handle production on the floor. Then there's enterprise resource planning, ERP, managing core business stuff like finance, HR, and product lifecycle management, PLM, which oversees a product basically from cradle to grave. These systems essentially allow different parts of the business to talk to each other in real time. It offers incredibly smooth workflows and consistent processes. And what's fascinating is how smart devices incorporating AI, virtual reality, augmented reality, they aren't just for production anymore. They also provide invaluable training support and troubleshooting capabilities for the workforce. All of this funnels up so that key stakeholders, from plant managers right up to executives, can gain comprehensive insights from a single unified dashboard.
That sounds like a pretty significant undertaking, connecting all those different dots. So for manufacturers looking at this, is there a clear strategic roadmap they need to follow, or is it more of a, trial and error thing?
Oh, it absolutely requires a clear strategy. You can't just wing it. Implementing these initiatives isn't just about buying new tech. It demands an extensive digital strategy for data collection, analysis, and extracting truly actionable insights. And it all has to be aligned with the organization's overarching business goals. It has to bring value. What's fascinating is that, according to BCG, manufacturing companies with a clear digital transformation vision are 70% more likely to achieve their desired business outcomes.
70%?
Yeah. It's not just about doing something digital, it's about doing it with real purpose.
That really drives home the importance of strategy. But, okay, for many, the big question is, does this actually translate into tangible benefits, for the bottom line? Does all this investment really pay off?
Well, it certainly does. Absolutely. A Deloitte study found that manufacturing companies embracing digital transformation experience a very significant 23% rise in profitability.
23%.
And 19% greater efficiency compared to those that don't. These aren't small gains. They're really transformational.
Those numbers definitely speak for themselves. Let's break down how those benefits actually sort of materialize in a factory setting. Where do you see them?
Well, the advantage is truly spread across several key areas. It's multifaceted. First, cost savings. And it's not just, shaving pennies. It's about fundamentally shifting from reactive, expensive emergency repairs.
Right, the panic calls.
Exactly. Proactive scheduled maintenance. This minimizes those unexpected equipment failures, turning unpredictable capital costs into manageable operational expenses. Plus, identifying inefficiencies and optimizing workflows further reduces resource consumption, overhead, all that.
Okay, makes sense. Second, improved product quality. Continuous monitoring detects and corrects deviations in real time. This ensures products consistently meet high compliance standards. And the implementation of digital twins, which I know we'll get into, enables incredibly stringent quality checks. It radically minimizes defects before they even leave the production line.
So catching problems earlier.
Much earlier. Then third, enhanced operations. Integrating automation and IT streamlines workflows, which significantly reduces engineering costs. And beyond the immediate process, energy management systems can dramatically cut energy costs and, importantly, reduce environmental impact, too.
That's a big one, too.
Definitely. Finally, greater customer satisfaction. All this increased digital capability leads to quicker order fulfillment and more reliable, timely delivery. Enhanced process efficiency and real-time data analytics result in incredibly accurate order execution. And that, as you know, builds immense trust and loyalty with customers. Okay, those benefits sound, well, almost too good to be true sometimes. But with all these advantages, it can't be entirely smooth sailing, surely. What are the common hurdles? What trips manufacturers up when they try to implement this?
Yeah, that raises an important point. Despite the clear benefits, significant challenges do exist. It's not always easy. You're looking at potentially high upfront implementation costs, which can definitely be a barrier for some, especially smaller players. Cybersecurity threats are a constant and, frankly, evolving concern as more and more systems get connected. You're opening up new vulnerabilities.
All right, that's a huge risk.
It is. And crucially, there's often initial resistance from the workforce. People might feel threatened or just overwhelmed by new technologies and ways of working.
That's a really crucial point about the workforce, the human element. Can you maybe share how companies successfully navigate that? Is there a specific approach?
You're right, the human element is absolutely key. Manufacturers can overcome these hurdles, but it takes effort. Approaching the process in phases often helps starting small to build confidence and demonstrate value. Crucially, securing C-suite and cross-departmental support right from the very beginning creates a unified vision. Everyone needs to be on board.
Top-down support.
Yeah, exactly. And yes, offering comprehensive training to the workforce, not just on how to use the new tools, but why they're important for their roles and the company's future. It's really about empowering them, not replacing them. Additionally, resources like the U.S. National Institute of Standards and Technology, NIST, they offer a robust framework with guidelines for integrating advanced tech and fortifying cybersecurity. That can provide a clear path forward.
Okay, so there's help out there.
Yeah.
For someone listening who's thinking about starting or maybe advancing this journey, what's the practical roadmap? How does a manufacturer actually begin this transformation systematically?
Right. It definitely requires a structured, systematic approach to ensure success.
Yeah.
You can't just jump in randomly. First, assessment. You need to honestly evaluate your current processes, your existing infrastructure, and where you stand right now with digital integration. What are the baselines?
Know where you are first.
Exactly.
Yeah.
Second, setting goals. Establish clear, measurable goals that are directly aligned with your business needs. What do you really want to achieve with this? Is it cost reduction? Quality improvement? Faster turnaround?
Be specific.
Very specific. Third, selecting technology. Choose digital solutions that are scalable and interoperable. You want things that can grow with you and actually reduce costs in the long run, not lock you in. Fourth, pilot projects. This is so important. Don't try to change everything at once. Start small, maybe in one area, a controlled environment, to leverage digital transformation gradually. Learn from it. Adapt.
Test the waters.
Precisely. Fifth, data integration. This is critical. You need to ensure a seamless flow of all relevant data across your new and existing systems. Data silos are the enemy here. Sixth, training. As we said, provide ample opportunities for workforce upskilling. They need to adapt and feel comfortable and confident with these new tools. Finally, scaling up. Expand gradually based on the success and the feedback from your pilot projects. It's an iterative process, not a one-shot deal. That phased approach makes a lot of sense. Build momentum. Any real-world examples of a company successfully navigating that kind of roadmap?
Absolutely. The Ford Assembly Unit in Chicago, they followed a very similar model. They kicked off with predictive maintenance pilot projects, just in a limited scope initially. And then, based on the positive results they saw, they scaled it up. That ultimately increased their machine uptime by a remarkable 15%.
15% is significant. Very. And even something maybe less glamorous like regulatory compliance gets simplified through this approach. Think automated documentation, real-time monitoring, digital audits. Nestlé, for instance, has successfully used automated compliance reporting systems to streamline how they adhere to regulations. That used to be a massive manual headache.
Yep, I bet.
Yeah.
Okay, let's dive deeper into some of the specific technologies driving this shift. We hear so much about the Internet of Things or IoT in manufacturing. How is it making such a profound difference, especially when we talk about extending the lifespan of these expensive assets?
Yeah, integrating IoT is absolutely crucial for that enhanced asset longevity and, of course, overall operational efficiency. Think of it like giving your machinery a voice and senses it didn't have before. By embedding smart sensors directly into equipment, manufacturers gain real-time insights into machine health and performance second by second. This allows them to detect even the slightest faults really early, often way before they become major issues, and dramatically reduces that costly unplanned downtime. This is really how we move from traditional reactive maintenance, wait till it breaks, to true IoT-enabled predictive maintenance.
Right, predicting the future almost. And I guess what's truly insightful here isn't just what each little sensor does on its own, but how the integration of data from maybe dozens or even hundreds of these small devices creates that nervous system you mentioned for the factory floor, revealing patterns maybe no human eye could ever possibly detect alone.
Exactly. That's the power of the network.
Can you give us a quick overview of what kinds of these smart sensors are forming this nervous system? What are we actually talking about?
Sure, yeah. These intelligent sensors are the eyes and ears, providing that refined precision monitoring. You've got pressure sensors, capturing tiny fluctuations in liquids or gases, really vital in hydraulic systems for catching leaks early. Temperature sensors are pretty much everywhere, from food processing to metalworking, collecting crucial heat data to prevent overheating or ensure processes run optimally.
Okay.
Proximity sensors sense the presence of objects nearby, which enhances safety and helps automate assembly lines with pinpoint accuracy. Force sensors detect compressive or tensile force, pushing or pulling, widely used in robotics to ensure precise movements and prevent damage from too much force.
Right, like a robot knowing how hard to grip something.
Exactly. Infrared sensors use infrared wavelengths for non-contact measurement. They offer high sensitivity and speed, great in environments where physical contact just isn't possible or desirable. Slow sensors sense the movement of liquids, gases, or even solids through pipes, helping maintain optimal machine performance and preventing blockages. Then there are motion sensors. They detect moving objects or changes in position on the factory floor, often with location tracking abilities for assets or even personnel for safety. Smoke sensors identify smoke or particulates, absolutely essential in potentially explosive environments, sounding alarms way before a major incident might occur.
Critical safety measure.
Absolutely. And optical sensors operate on zero interference, using light for non-contact metrics. They're great for optimizing positioning in high-speed lines where precision is paramount. Finally, image sensors. These convert optical images into electric signals. They're the backbone of computer vision, quality control camera modules, and even things like medical imaging, if that's relevant within manufacturing context.
Wow, that is an incredible amount of data being generated constantly from all those different points. How is all this raw sensor data actually being put to practical use in real-world factory settings to drive these huge benefits we talked about?
Yeah, it's a flood of data, you're right. But when it's analyzed correctly, it offers a plethora of advantages. Everything from boosting workplace safety to achieving unparalleled operational transparency. Consider 3M, for example. They really transformed their safety protocols by integrating RFID tagging, smart sensors, and real-time data analytics. It created a demonstrably safer environment for their workers.
That's a great example.
And specific applications of this data include, well, asset management, continuously tracking the condition and the location of equipment to optimize usage, and, crucially, schedule proactive maintenance before problems arise.
Knowing where everything is and how it's doing.
Exactly. Supply chain management. Using things like GPS and RFID tracking provides real-time visibility of goods, whether they're in transit or storage. This dramatically reduces bottlenecks and improves delivery times. Predictive maintenance. Like we said, sensors monitor machine health, things like vibration, temperature, even sound signatures to predict failures, often weeks or months before a breakdown would actually occur. This is where you truly move from reactive repairs to strategic, scheduled maintenance. Huge cost saver.
That's the game changer, isn't
It
it?
really is.
Yeah.
Then, production line optimization. Sensors and industrial robots can automatically adjust parameters in real time based on feedback, reducing errors and significantly increasing production speed. Quality assurance. Sensor data helps continuously check products against quality standards. This allows for immediate, sometimes automated adjustments for any inconsistencies, ensuring a near-perfect output. And finally, worker safety. Wearable sensors can monitor workers' health metrics or environmental conditions around them, providing immediate alerts for potential risks or hazards. This directly improves safety right there on the shop floor.
And it seems like it all funnels into one critical outcome, which we keep coming back to: reducing downtime, which, as we discussed, is just a massive win for manufacturers.
Exactly. Yeah, real-time data monitoring is really the cornerstone of the modern, efficient industry. Can't overstate it. Toyota's plant in Kentucky, for instance, successfully reduced downtime by a remarkable 28% after implementing real-time monitoring systems. That's huge.
28%. Wow.
And this real-time monitoring, it applies across multiple crucial areas. For production monitoring, you've got real-time dashboards tracking output, identifying bottlenecks instantly, allowing for immediate adjustments. Siemens saw significant reductions in machine downtime by integrating IoT sensors and advanced analytics across their plants,
Seeing problems as they happen.
or even before. In condition monitoring, regular automated assessment of machine health actively prevents unexpected failures. BASF uses remote condition monitoring for its plant down in Beaumont, Texas. They identified anomalies in 63 prime assets, catching issues super early. For quality control, that early defect detection maintains incredibly high quality standards. General Motors adopted real-time quality control, and it led to a marked decline in defects per vehicle. Tangible results.
Fewer recalls, better reputation.
Definitely. Downtime tracking goes beyond just knowing when something stopped. It's about analyzing the root causes in real time to prevent future breakdowns. Carolina Precision Manufacturing, they use data analytics to eliminate material waste and drastically reduce downtime simply by understanding the why behind the stops. And of course, predictive maintenance. Scheduling maintenance based on actual wear and tear data truly extends equipment lifespans, saving millions. General Motors, again, uses IoT, industrial IoT, to predict maintenance needs across its plants, saving huge amounts and dramatically improving overall efficiency.
Makes sense.
Even workforce management benefits. Monitoring worker efficiency, automating labor planning, improves overall productivity, and can even reduce injuries. AI, combined with sensor data, helps mitigate labor shortages too, by escalating defects or addressing machine issues before they necessarily require human intervention.
Okay, this brings us perfectly to a concept that's truly capturing the imagination of the industry right now: digital twins. Imagine being able to test every change, predict every failure, and optimize every single process before it even happens on the actual factory floor. It sounds almost like science fiction. What exactly is a digital twin, and how is it transforming manufacturing today?
That's a perfect way to put it, actually. It does sound a bit sci-fi, but it's very real now. A digital twin is essentially a dynamic virtual replica of a physical asset, a process, or even an entire system, like a whole production line. It provides real-time simulation, advanced diagnostics, and powerful predictive analytics because it's constantly mirroring its physical counterpart using live data feeds.
So it's a living model.
Exactly, a living model. This enables truly data-driven decisions that then impact the physical world. Rolls-Royce, for instance, uses digital twins extensively for their jet engine maintenance. And it's allowed them to reduce maintenance costs by 30% and extend maintenance intervals by up to 50%.
Yeah.
That's an absolutely incredible impact when you think about the sheer complexity and cost involved with jet engines.
30% cost reduction and 50% longer intervals. Those numbers for Rolls-Royce are genuinely staggering. But thinking about maybe a smaller manufacturer, is a digital twin still attainable? Or is it primarily a solution just for these huge industrial giants right now? Can you give us a few more examples of how companies, maybe big or small, are leveraging digital twins?
Yeah, it's becoming increasingly accessible, though obviously the scale and complexity might differ. The fundamental principles, though, apply across a wide range of operations. General Electric, another giant like Rolls-Royce, monitors jet engine performance with digital twins. They've seen increased engine uptime and reduced reactive maintenance by around 40%.
40%.
Yeah. BMW uses it extensively in vehicle manufacturing, reducing production errors and dramatically improving overall quality control. Maserati applies it to their car development process. They've cut operational costs and time and actually decreased their time to market by a remarkable 16 months using digital simulation and testing.
16 months faster to market. Wow.
It's huge. Unilever, in the consumer goods space, uses digital twins to optimize production in their plants. They've reduced new product launch time by 50% and cut capital expenditures by 70% in some areas by simulating first. Ferrero, the confectionery giant, they utilized digital twins for commissioning a new high bay warehouse. It brought down the commissioning time by 30% and helped them achieve their target availability 88% quicker than they expected.
So even for logistics and infrastructure.
Absolutely. And Kaiser, a compressor manufacturer, applies it directly to their products out in the field. This allows remote detection of potential faults, proactively prolonging the product life and significantly reducing maintenance costs for their customers. Adds value. So you see, the integration of digital twin technology is far more than just a trend. It really is a marked shift towards increasingly connected, smarter, and profoundly more resilient operations across the board, big and small.
Okay, so if we connect all this to the bigger picture then, all of these advancements, the IoT, the AI, predictive analytics, these digital twins, it really sounds like what we often hear referred to as Industry 4.0. Is that basically what we're describing here?
Exactly. That's precisely it. Industry 4.0 is the umbrella term for this powerful ecosystem. It's bringing together IoT, AI, robotics, cloud computing, all of it into a truly smart, connected factory environment. And like you said earlier, this isn't just about achieving more speed or efficiency, though it does that. It's profoundly about extending the lifespan and optimizing the performance of every single asset on that manufacturing shop floor, getting more out of what you have. For plant owners and managers listening, investing in these intelligent technologies today, like the ones we've discussed, it isn't just about staying competitive anymore. It's really crucial for greater success in building a smarter, far more resilient position in their respective domains, whatever they make. Just look at the Siemens plant in Germany, a famous example. It relies on 75% automation for its production process, and it achieves a remarkable quality rate of 99.99885%.
Almost perfect.
Almost perfect. That's the power of Industry 4.0 in action.
Well, as we wrap up this deep dive, it's incredibly clear that the future of manufacturing isn't just about going faster, but about building true resilience, powered by these very technologies we've been talking about. We've seen how digital transformation, really propelled by predictive analytics, the smart sensors, and these amazing digital twins, is not just cutting costs and boosting efficiency, but genuinely extending the useful life of critical assets and radically reshaping what's even possible in production.
It truly highlights how manufacturers are moving towards a fully integrated, data-driven environment. It ensures consistently higher quality, definitely greater customer satisfaction, and ultimately a much more sustainable operational model for the long haul. It really is a significant leap forward in how we manage these complex industrial systems.
So what does all this mean for you listening right now? Maybe next time you hold a manufactured product, anything really, consider the unseen digital infrastructure that likely helped bring it to life. And think about how our very understanding of lifespan for industrial machinery is being completely redefined, moving away from simple repair towards strategic life extension and optimization. And perhaps ask yourself this: what kind of existing systems or processes in your own world, whether that's personal or professional, could potentially benefit from a similar digital twin approach? Creating a virtual replica to predict, optimize, and maybe extend its life. Definitely something to mull over until our next deep dive.